Good day, grade 9. For this video, we are going to discuss the different laws of logarithms. Particularly, we are going to apply these different laws, including the change of base formula to our logarithmic functions. Okay, let's start. So let's say we have here three equations, equation 1, equation 2, and equation 3. So if we try to combine equation 1 with equation 2, so this becomes log base 5 of 5 plus log base 5 of 125. Then it will result to equation 3, which is log base 5 of 625. Okay, so if we analyze, equation 1, log base 5 of 5 is just equal to 1. Okay. Equation 2, log base 5 of 125, if you evaluate that, that is equal to 3. So 1 plus 3 gives us 4. And if we notice, log base 5 of 625 is equal to 4. So as we observe here, if we try to add two logarithms of the same base, okay, take note, the base here is 5, and also here, the base is 5. So what happens to your resulting answer or your answer? Okay, so your answer becomes this one. So the base remains, however, the argument or the value inside your logarithm changes. Okay, so 625 is equal to the product of 5 and 125. Okay, so that is our first law or the product rule of logarithms. So the product rule states that if we have log base b of m and we add that to log base b of n, then the resulting answer would be log base b of the product of m and n. Okay? So we are going to multiply the two arguments. Okay, so this is similar to your product rule of exponents. So if we want to get the product of two exponents, okay, so same base, we add the exponents. Okay, so let's try to have an example here. So sabi sa problem 1, let's try to simplify the logarithm. So log 2 plus log 7 plus log x. Okay, so we want to combine these three logs into just a single logarithm. So paano natin gagawin yun? So we apply the product rule. Okay? So since we have here same base, so again, kapag wala tayong nakita, ang base natin ay 10. So it is a common logarithm. Okay, so same base, what we are going to do with the arguments, we need to multiply them. Okay, so the resulting value would be log, okay, base 10. Okay, kung base 10, hindi ko na isusulat yung 10 dito sa baba. Okay, so this is log of 2 times 7 times x. Okay, so this is log of 14x. Okay? So similarly, dito naman sa item number 2, so the natural log of e squared plus the natural log of 6e plus the natural log of 0.5. So yung log base e, pwede natin itong isulat as ln of 0.5. So lahat ng terms natin ay naka-natural log or ln. Okay, so our result would be in terms of natural log also. So ano yung gagawin natin sa arguments? We multiply them. Okay, so we have e squared times 6e times 0.5. Okay, so this will give us 3. So ln of 3e cubed. Okay, so 6 times 0.5, that is 3. E squared times e, that is e cubed. Okay, and for item number 3, so we cannot apply here directly yung ating product rule for exponents since we have different bases. So what we are going to do is to transform this term and this term such that meron silang base na 2. So paano kaya yon? So we can write this as 2 raised to x. Okay, so I just copy the first term times. So for this second term, 4 is 2 raised to 2. Okay, so I have here 2 raised to 2 raised to the variable x. Okay, so I have here 2 raised to 2x. Okay, and for 16, so 16 is 2 raised to 4. Okay, so I will write here 2 raised to 4. So anong mapapansin natin? Same bases na sila. So what we are going to do if we want to get the product, we just copy the common base. And for the exponents, we are going to add them. So x plus 2x plus 4. So this will give us 2 raised to 3x plus 4. Okay? So how about if we try to subtract the given equations? Equation 3 minus equation 2. So we have here log base 5 of 625 minus log base 5 of 125. So again, equation 3 gives us 4. Equation 2 gives us the value of 3. So 4 minus 3 is obviously equal to 1, which is the same as log base 5 of 5. So ano naman yung mapapansin natin dito? So again, all logarithmic terms have common base, which is 5. Pero if we try to see the left side of our equation, so ang arguments natin would be 625 and 125. Okay, so if we try to divide 625 by 125, so this will give us 5. Okay, so using this one as our example, we now go to the quotient rule of logarithms, which state that if we get the difference of log base b of m minus log base b of n, then the result would be log base b of the quotient of m divided by n. Okay? In analogy, this is also applicable for the quotient rule of exponents, wherein if we want to divide two expressions with exponents, okay? So same base, we copy the common base, and we are going to subtract the exponents. So exponent of the numerator minus the exponent of the denominator. So tignan natin. Applying quotient rule, so write these expressions as a sum or difference of logarithms. Okay? So let's start with item 1. So I have here log of xy all over 4. So I can break this down into a difference of two logarithms. So I can write this as log xy minus log of 4. Okay? However, if you try to notice, this is a product. Okay, so yung nasa loob, so that is the product of x and y. So applying our product rule inside, so I can write this as log x plus log y. Okay, so therefore, this item right here, log xy over 4, I can write that as a sum and difference of 3 logarithms. Okay, so that is equal to log x plus log y minus log 4. Okay, so how about for the second item? So similarly, I can write this as ln u squared v minus 2u minus ln of u v. Okay, so kung mapapansin natin, this term right here, okay? So the argument is uv, so that is u times v. So I can apply product rule further. So this becomes ln u plus ln v. Okay? So, dito naman sa first term, so hindi natin pwedeng i-break down to. Okay, so take note, this is not equal to this one. Okay, so again, this is wrong. Okay, so you cannot separate the term anymore inside of this logarithm. Okay, so our final answer would be ln of u squared v minus 2u minus the quantity ln u plus ln v. Okay, so let's try to answer this challenge question. So what is the value of log xy all over 10z if log x equals 3, log y is 7, and log z is equal to 2? So paano kaya yan? So we try to break this down into sum and difference of logarithms. So doing that, so since meron tayong division symbol dito, then we can apply first the quotient rule. So this becomes log xy minus log 10z. Okay? And applying the product rule further, since yung argument natin is x times y, okay, so I can write this as log x plus log y. Okay? And for this term right here, so I can write that as log 10 plus log z. Okay? So again, 10 times z. So I just separate it, 10, and then z. Okay? So alam natin that log x is 3. So sulat natin 3. And then log y is 7. Okay, so sulat natin 7. Minus the quantity. What is log 10? So this is log base 10 of 10. So applying the property of logarithms, this is equal to 1. Okay? Plus log z, which is equal to 2. So simplifying this arithmetic, okay? So this is 3 plus 7, this is 10 minus 3, which is equal to 7. Okay? So the value of this logarithmic expression is equal to 7. Next, so going back to your product rule, what if m is equal to n? So if m is equal to n, pwede nating palitan to ng m such that our left-hand side of the equation becomes log base b of m plus log base b of m. So applying product rule, so since common base na b, so just copy the common base and you multiply or get the product of the argument. So m times m becomes m squared, right? However, one way to simplify this is by having this one, okay? So dalawang log base b of m becomes 2 log base b of m. Okay? So these two terms are equal. So anong nangyari kaya? So if you notice here, the exponent doon sa loob ng argument, which is 2, so essentially we are going to transfer this outside. Okay? So yung exponent na 2 pumunta dito sa labas. Okay, so this becomes 2 log base b of m. So that is our power rule. So if you have log base b of m raised to k, okay, so you can transfer k outside of the argument such that it becomes k times log base b of m. Okay? So applying the power rule dito sa mga examples natin. So evaluate or expand log base 2 of x raised to 5. So again, the exponent here is 5. We can transfer that here outside. So this is equal to 5 log base 2 of x. Okay? So for number 2, so I can first write this single log as log base 4 of u squared plus log base 4 of v cubed. So again, I just applied the product rule. Okay? And then applying further the power rule, yung exponent natin na 2, pwede nating ilagay sa labas. Ganon din yung exponent natin na 3. Okay, so this becomes 2 log base 4 of u plus 3 log base 4 of v. Okay? And last example, so my division symbol. So first apply the quotient rule. So this is log base 8 of 3m minus log base 8 of 2NOE. Okay? So applying the product rule here, so this is log base 8 of 3 plus log base 8 of m minus the quantity log base 8 of 2 plus log base 8 of n plus log base 8 of o plus log base 8 of p. Yan, so in-expand natin. So napakahaba na. So simplifying this, log base 8 of 3, can we evaluate this without using our calculators? No. So ganito na. So it remains as is, no? So itong log base 8 of 2, can we evaluate this without using our calculator? Yes, no? Because log base 8 of 2 is equal to 1/3. Right? But for this example, I will leave the answer as this one. Okay? Next, so we are done with the 3 rules. Okay? So again, we have the product rule, the quotient rule, and the power rule. So this time, this change of base formula is also essential for us to simplify and evaluate our logarithmic functions further. So ano ba yung sinasabi nitong change of base formula? Okay, so this formula applies for any positive real numbers m, b, and n such that your base is not equal to 1 and your n is also not equal to 1. Okay, so tignan natin. So if we have this logarithmic expression log base b of m, so by change of base formula, we can write that as log base n of m divided by log base n of b. Okay? Example. So let's try to express this logarithmic expression, log base 2 of 6, as a quotient of natural and common logarithm. So again, this is our change of base formula, okay, wherein b is equal to 2, okay, and m is equal to 6. So applying this one, so log base 2 of 6 becomes log yung n natin dito sa first line. So n here is equal to 6 or e rather. Okay? So n here is e. Yun yung naging base natin. Okay? So log base e of 6 over log base e of 2. Okay? So again, m yung nasa numerator, b yung nasa denominator. And take note that our base here should be equal, no? So if ang base mo sa numerator ay e, so ang magiging base mo dapat sa denominator should be e also. Okay, so we can write this as ln6 all over ln2. Next one. So ganun pa rin, however, in this second case, I changed e to 10. Pwede ba yun, sir? Yes, pwede. So you can use any base here as long as the base that you used in the numerator is the same as the base you use in the denominator. Okay, so pwedeng maging 3 yan, maging 2, maging 4, maging 10. Ayun. Okay? as long as it is the same sa numerator and sa denominator. So let's try to answer this challenge question. So we are going to approximate the value of this logarithm without using a calculator. So given sa atin ito, so ln of 5 is 1.6, ln of 11 is 2.4. So we are going to evaluate the log base 11 of 5. Okay? So paano yan? So let's try to apply the change of base formula. No? So log base 11 of 5. So I can write that as log 5 all over log 11. Okay? So pwede yan as long as the same yung base dito sa taas at dito sa baba. So ibig sabihin yan, I can also write this as log base e of 5 over log base e of 11. Kasi same naman yung base ko sa numerator at denominator. Okay, so using this one, so again, kapag log base e, that is the natural log. So that is ln 5 over ln 11. Okay? So this means that the given log base 11 of 5 is equal to ln 5 divided by ln 11. Okay, so this is 1.6 divided by 2.4. So 1.6 divided by 2.4. So this gives us 2 divided by 3 or 2/3. Okay? So 2/3 ang sagot natin dito. Last problem for this topic. So we are going to prove that this one is equal to this one. Okay? So let's try to manipulate the left side of our equation. Okay? So log base b of n. So applying the change of base formula here. So log base b of n becomes log of n divided by log of b. Okay? Sir, pwede ko bang isulat as log base n of n over log base n of b? Yes, pwede as long as same base sa numerator at sa denominator. So I can write this, no? So if I use n as my base, my numerator becomes log base n of n, which is equal to 1. And for my denominator, that is log base n of b. So in fact, log base b of n can be written as 1 over log base n of b. Okay?